Welcome to another episode of Podcast Name. Today we're diving into the fascinating world of 3D object detection and how new technologies are transforming our understanding of indoor environments. If you've ever marveled at the capabilities of augmented reality or wondered how your smartphone can recognize objects with such impressive accuracy, you're in for a treat. Let's kick things off by discussing a groundbreaking research paper titled "Cubify Anything: Scaling Indoor 3D Object Detection," authored by Justin Lazaro and colleagues. This paper unveils a revolutionary model called the Cubify Transformer, or QTR for short, which leverages a dataset known as CA1M. But what exactly does all that mean? So, to start with, think of QTR like a superhero in the realm of computer vision. Whereas traditional methods might struggle with accurately identifying and classifying objects in detailed indoor settings, QTR swoops in to analyze 3D spaces and recognize various items with impressive precision. Exciting stuff, right? Now, the CA1M dataset is a big part of what makes this technology tick. Unlike previous datasets that left much to interpretation, CA1M comes with meticulously annotated 3D boxes for every object within a scene, registered in a laser scanner's coordinate frame. This means not only can the model detect objects, but it can also accurately understand their position and orientation in 3D space. Imagine you're in a busy living room filled with furniture, a pet, and perhaps some clutter on the coffee table. If equipped with this technology, your device could pinpoint each item, from the sofa to the picture frames, and tell you exactly how they relate to one another in 3D. It's like having a personal assistant helping you navigate your space. But let's explore this a bit deeper. One intriguing aspect of CA1M is that it includes per-frame 3D box ground truth data. What's fascinating here is that this is independent of the camera's position or orientation. So, even if you shift around the room, the model can continuously adjust and update its understanding of the environment. Well, you might be wondering, how do we actually use the CA1M data and models? Installation is relatively straightforward. You need Python and PyTorch. Those are the foundational tools. After that, you can pull in the necessary dependencies and kick off the process. It sounds a bit technical, sure, but essentially you're setting up everything to ensure that the model runs like a well-oiled machine. Oh, and here's a fun fact. The model supports different types of images. There's an RGBD variant, which takes both color and depth images, making it even more powerful. If you're working with devices that have LiDAR capabilities, like some smartphones, you can feed this valuable depth information into the model for even greater accuracy. For those of you excited about applying this tech from your own devices, the Nerf Capture app is available to facilitate this. With just a few commands, you can stream live footage and let the model analyze your surroundings in real time. How cool is that? All right, as we wrap up this episode, let's reflect on what we've uncovered. The Cubify Transformer and the CA1M dataset harness the power of advanced 3D object detection, allowing us to analyze and interact with our environments in ways that were previously the stuff of science fiction. This technology not only enhances augmented reality applications, but could also pave the way for smarter and more responsive environments in the future. Before we sign off, I invite you to think about how you might see this technology being used in your life. What sort of applications do you find most exciting? Maybe smarter home automation or improved navigation in complex spaces. Thank you for tuning in today. We hope you found this discussion as fascinating as we did. Join us next time for more insights into the world of technology and innovation. Until then, Tay.